Now we'll talk about midsegments. This is a triangle I created in GeoGebra, and all I did was make point D, so it's always in the middle of A and B. So you can see if I stretch B here, D moves, so it's in the middle. I also made point E, so it is also in the middle between points B and C. So D is a midpoint of segment AB, and E is a midpoint of segment BC. Anytime you connect these midpoints on a triangle, you have made a midsegment. Now, one of the interesting things you can see here is I went ahead and marked the lengths of the two segments. So you have 5, segment DE. Now, this is going through a little rounding, so let me make this an even number. Works better with evens. Then the length of the midsegment is always half of the length of the side that it's parallel to. Now, how do I know that it's parallel to this side? Well, I'm actually measuring the angles here. Angle A is congruent to angle D. You can see as I move it, it stays the same. And if you have two lines, and this is a transversal here, then that means these are corresponding angles. And if corresponding angles are congruent, the lines must be parallel. So the interesting thing about midsegments is that they are always parallel to the side they're not touching, and they are half the size of the base. If I wanted to, I could actually add another midpoint here. Let's see if I did that properly. Let me add a midpoint. And there it is. And if I connect it, so I'll have a segment, connect that point, and then connect this point. The cool thing you'll see is that it will also have the same characteristics. So if I do the length here and the length here, whoops, I hit the perimeter, the length of that one, and then the length of here and here, and stretch out my triangle, you'll see that there's this sort of relationship that occurs with the lengths. And oops, here we go, this stays down here. The red ones are for the outside and the black ones are for the inside. So you can say that 9 is half of 18. See how the 9 goes with the 18, the 5 goes with the 10, and the 8 goes with the 16. If I were to do the angles, you would also find the same thing. This segment FE is parallel to AB, and segment DF is parallel to BC. So as you saw in that video, the midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. All right, and you can see here D and E are midpoints, and D is the midpoint of AB, E is the midpoint of BC. The Midsegment Theorem says that the midsegment of a triangle is always parallel to the side of the triangle. So these two sides will always be parallel, and this length is half of this length. So let's go ahead and apply this to an example. First of all, I want to find the length of BD, and I can see that the length of AE is 17. Well, I know that BD, this is a midsegment, so it's half of the length of the base here. So it's half of AE. I substitute in 17. Half of 17 is 8.5. So the length of BD is 8.5. Now I'm going to use the property that the midsegment is parallel to the side. So if I know that this angle is 26, first of all, I'm trying to find angle CBD. So I'll do a transversal that connects that angle to it, and there it is. And you can see that I could actually have some parallel lines here. Let me go ahead and highlight those. The parallel lines are this segment ABC and FD. Remember, this midsegment is actually parallel to that base there. Well, now you can see that CBD and BDF are alternate interior angles, which means they're congruent. So that means that CBD is 26 degrees. For our last example, I have the vertices of triangle XYZ are -1 and 8, 9 and 2, 3 and -4, and I also know that M and N are midpoints of XZ and YZ. So I need to show, first of all, that MN, segment MN, is parallel to XY, and MN is half of the side that would be the base to it. So first of all, let's plot the 3 points, and you can see there's my triangle. Find your midpoints. So I'm finding the midpoints of XZ and YZ, and I connect them. There's my midsegment. If I'm trying to show that things are parallel, I want to use slopes, especially when I'm dealing with coordinate geometry, when I have the coordinates. So looking at the big base right here, you can see this yellow line shows the rise and the run. The rise is negative. So, and here is the smaller midsegment, and you can see the rise and run here. So this rise is 6, really -6, and the run is 10. And my slope is -3/5. The slope for the midsegment, the rise is 3, or really -3, and the run's 5. So I have -3/5 as the slope. Since the slopes are the same, then XY is parallel to MN. So we actually have shown that part of the problem. The next thing I'm going to do is find the length of these. I'm going to use the Pythagorean theorem. If you prefer, you can use a distance formula, but that does take more room. So I'm going to use my yellow triangle first to find the distance of XY. 6 squared plus 10 squared equals XY squared. Squaring both the numbers, I get 36 plus 100 is XY squared, or 136 is XY squared. I can take the square root of both sides to find the length of XY, and using my calculator, I get approximately 11 7/10. I do the same thing for the midsegment. 3 squared plus 5 squared equals MN squared. 9 plus 25 is MN squared, which is 34. Take the square root of both sides, and I have about 5.83. If you double that, you will have about 11.7. So you can see that MN is half of XY. Now I'll leave you with this reflection. An isosceles triangle has 2 congruent sides. Does it also have 2 congruent midsegments? It might help you to go ahead and draw an isosceles triangle and make sure that you draw all 3 midsegments. And let me